things that are kind of similar about them. But let's start with an example like this. So usually your instructions on these are just going to say simplify, and then we'll have something like this. So if we have 3a to the 5th power, b to the 2nd power, c to the 2nd power, and then that's all in parentheses raised to another. The whole thing is raised to the 2nd power. Okay, but then that's not all, and we've got a little bit more here. And then we're also going to have inside parentheses 2a to the 4th, b to the 3rd, c, and then everything in this parentheses raised to the 3rd power. Okay. So let's do this one together just to remind you about some of those properties of exponents that we talked about last time. And some of you weren't able to come last time, or you were having problems getting on, and so you messaged me about that. I hope you were able to watch the lecture after the fact, but I know that's hard because then you don't get your questions answered if you need them. So let's go through some of this together, just reminding you about some of these. So first thing that you're going to want to do is clear the parenthesis by distributing this power of 2 to everybody. So remember, we've got to give it put a power of 2 on the 3, right, the 5, this 2, and this 2. So let's start that out, right? So what's 3 to the 2nd power? Do we have that? Have somebody help me work through this one. Raise your hand if you think you've got a pretty good hold on what to do here. Anybody willing? So I'm not talking to myself. All right. Who was that? Can't see everybody. All right, Paige. Thank you. So unmute yourself and tell me what you think you would be doing here. What will you get when we raise the power of 2 to all of these things inside?
So would it be 9 and then a to the 25?
So not to the 25, so let's think about that again. So when we do a power raised to a power, what are we doing with those exponents? Remember? So let me write this here to the side. So if we said a to the 5th all squared.
Oh, are we adding?
So we'll be multiplying when it's a power raised to a power. I know, and it's tricky trying to think about these. But remember we said, oh yeah, I could write this down as a to the 5th squared just means a to the 5th times a to the 5th, right? And then there's 5a's here and 5a's here, and so there's 10 of them all together. Okay, so 9, and then a to the 10th. Okay, then what would the next one be? B to the 4th, and C to the 4th also, right? Because again, and that one's kind of, it's hard to tell if we're adding them or multiplying them, but remember, whenever it's a power raised to a power, this is when we're going to multiply. I'll write that down here next to it, just to remind us from last time. Because trying to keep all of these straight in our head is going to be probably the most difficult part about these properties of exponents. Okay, so what about this next one? Would you be willing to help us out with that next part? 2 page? Yeah. Okay, so what do you think we're going to get here? So 2 to the 3rd power is 8. And then so it's
b to the 12?
Yeah, because it's still a power raised to a power. So we're doing the 4 times 3. So a to the 12th. And then b
to the 9.
And c
And then c to the 3rd.
To the 3rd, right? Because there's kind of like an invisible 1 here, and we're doing 1 times 3, right? And now we've got to combine all of our like terms together, right? So I'm going to do my 9 times my 8, so that'll give me 72. And then I'm going to try and do some different colors here to make it easier for you to see. So I'm going to get my a's together. So now I'm doing a to the 10th times a to the 12th. I'm going to write those over here just to hopefully make sure you can see the difference. right? So when it's a power raised to a power, we're multiplying it. But when we have the same base and, with different exponents, then we're adding those exponents together. Right? So in this one, we'd get a to the 22nd. Right? And then our b, again, we're going to add those together. So b to the 13th. And then c, right? So c into the 4th and to the 3rd. So we're going to add those exponents. So c to the 7th. And I know that I'm all the way done because I don't have parentheses anymore and there's no negative exponents and all of my variables are together. So that's how I kind of know when I'm done. Some students go, well, sometimes I get confused, like when am I done? I don't know if I need to keep going or not, right? But we can't combine our A, B's, and C's together anymore. So we're done at that point. All right, other questions did you have on this as you were looking at this, going, oh, trying to remember these properties of exponents? And maybe what I'll do really quick over here, let's just have these handy to look at. Okay, so let's look at our rules of exponents. Okay, we wrote these down last time, but I'm going to keep referring back to these. And I might have these in a different order than what I did last time, but the order doesn't matter in which I'm writing down these, just that I have them all here. So when we have like x to the, well, actually let's do a different one than x, because x is usually one that we always have there. So let's do a to the n power times a to the m power. So we said on something like that, we're going to be adding those together. So a to the n plus m power. When we have a power raised to a power, so a to the n, in parentheses, all raised to the m, then we're multiplying those exponents together. So a to the n times m power. Right? When we have division, something like a to the n over a to the m, so when it's connected by division, then we're actually going to subtract those exponents, doing the top minus the bottom. So a to the n minus m. Okay. And sometimes we might have things multiplied together, like we had here with some exponent on the outside. So we've got to distribute that exponent to everybody. So a to the n times b to the n. Then we could have it also connected by division, all raised to a power. Same thing, we've got to give that power to everybody. So this time we have a to the n over b to the n. Okay. Then we also said if we have anything raised to the 0 power, that'll be 1. And if we have a negative exponent, so a to the negative n power, that negative exponent is just telling you to flip the whole thing. So that would be 1 over a to the n power. Right? So those are kind of the rules of exponents, these properties of exponents that we talked about last time. And we're going to still be, dealing with these today. So I'm going to just have those there so I can refer back to them as we're looking at some of these, because we're going to be using a lot of different properties in the same question, like you kind of saw here on that first example. Okay. All right, let's try another one. See what we can do here. Oops, example 2. So let's try doing one with, it looks like this. So again, it'll say simplify. And then we'll have in the top, so this is going to be a fraction, but on the top in parentheses, I'm going to have x squared, y to the 5th, z to the 5th, all raised to the 6th power. Okay, so just all of that stuff on the top is being raised to the 6th power. On the bottom, in parentheses, I've got x to the 5th, y to the 5th, z, all raised to the 6th power. Okay, so tell me a place that you think you might start on this. There's more than one right place, but there's one place that I think would be easiest to start. Anybody have an idea? Let's go ahead and unmute yourself and tell me.
Would you start by distributing like the parentheses, like the 6 on top and the 6 on the bottom?
Yeah, so we got to take that 6, so just like we did up here in the first example where we distributed that through, and that helped us get rid of the parentheses. So that's exactly what we want to do on the bottom. So everybody do that to start off with. Okay, distribute that power of 6 to everybody. But remember, a power raised to a power, you're multiplying those numbers together. I'll give you a minute to try and do it. Okay, so when you distributed them through, you should have this, but then we're not done because we've got to get the x's together, the y's together, and the z's together. So we still have to continue on further. But is everybody clear with where I got the 12, the 30s, the 6? Okay, so now let's focus on the x's, right? So remember, we could do that property, this one right here, where it's saying do the top minus the bottom. But I talked about something last time that I said is usually easier for most students, so they don't have to work with negative exponents. So you're thinking to yourself, right, where are there more x's, on the top or on the bottom? On the top? No? The bottom? Yeah. Okay. There's more. Yeah, on the bottom, there's more x's. So we know that our x is going to end up on the bottom, right? And then really we're just subtracting those two numbers. So we're doing, what's 30 minus 12? What is that? 18. And so that would be our exponent on x. So there's 18 of them left on the bottom. Right? Because think about like when we did before, like if we had like, you know, x times x and then x times x times x times x, right? We said, okay, these guys divide out and there's still 2 of the x's left on the bottom, right? And that's really what we're doing, but we're just not having to draw out the picture. We're just saying, okay, there's more of them on the bottom. How many more? Let's subtract those to find out. Okay, so what about with the y's? What happens there with the y's? Anybody?
They cancel each other out.
Yeah, they're just gone, right? Y to the 30 divided by y to the 30, everything's going to be gone. There's not going to be any y's left. So y is no longer going to be part of our answer. Okay, and then with our z's, right, again, we're looking at this, right? Where are there more z's? On the top or on the top? And how many more are there? 24. We're doing 30 minus 6. Okay. And so then that would be our answer there. Okay. So like I said, you could have, you know, done this by doing like 12 minus 30, and that gives you a negative 18 on the top, but then you have to flip it to the bottom. So a lot of students just kind of get hung up with this when you have those negatives. So try and think about it this way. Where are there more of those, you know, and how many would be left if you subtract it? Okay, what other questions do you have here on example 2?
Hi, Becky.
Hi.
This is Elizabeth.
Hi, Elizabeth.
I have a question with like the y's. So like 30 minus 30 is like 0.
Uh-huh.
Like that.
So that would give us y to the 0 power, and anything raised to the 0 power is 1.
Yeah. I'm just wondering why that wouldn't end up being 0 with the y's, like just because it, like they cancel each other out.
Well, because anything divided by itself is 1. So imagine if we had, I don't want to draw 30 of those out, but if I had, say it was y to the, or x to the 5th, or I'll do 4th, x to the 4th over x to the 4th, right? Well, we can see on this, right, that each of these end up dividing out, and when they're dividing out, well, they're leaving ones. X divided by x is 1. X divided by x is 1. Right? And then 1 times 1 times 1 times 1 is 1. So 1 is what we're left with. So just remember, anything divided by itself is always 1. If you're doing the subtraction, that's fine, but it's not that, you're doing 0, it's y to the 0 power, right? You're saying y to the 30 minus 30 gives you y to the 0 power, and then anything to the 0 power is always 1. So you're basically just canceling everything out. We're just leaving a 1. And you don't need to write that 1 in there. You could if you wanted to, but you don't have to write the 1. Because there's no, the y's are all gone, right? Everything divided out, just leaving a 1. Does that make sense? That's kind of a weird...
Yeah, that makes sense.
Yeah. Other questions on that one? Okay, let's look at, I want to make sure we get to some with more negative exponents, because that tends to be where, a lot of issues come up. So let's do one that has some negative exponents in it. Do this one together. So we're simplifying. So on the top, I'm going to have in parentheses 2y to the 7th. And then that whole thing is being raised to the negative 3rd power. And then on the bottom of my fraction, I'm going to have y to the negative 2 power. Okay. So there's a couple of different ways you could think of this. Right, I can see that since this is all in parentheses, that 2y to the 7th, and it's all being raised to a negative exponent, I know that that whole thing is going to flip downstairs. So let me kind of write some little, So since it's a negative exponent, it's unhappy upstairs. So I'm going to flip it downstairs. So the stuff inside here stays the same. It still stays at 2y to the 7th. But now, instead of being raised to a negative 3rd power, it's now raised to a positive 3rd power. Right? So just by flipping that downstairs, it changed that negative into a positive. Right? And then kind of the same thing goes on this. Y is negatives, unhappy downstairs, so we're going to flip him upstairs, and that will be y to the 2nd now. Okay, so that's what I like to do first. I personally like to get rid of negative exponents first, because there's just a lot of problems that tend to come from it, and students, tend to make more mistakes when they keep the negative exponents in there. But you know yourself, if you're like, I'm really good with negative numbers, and I don't make, that many mistakes when I deal with negatives, then you don't have to do it this way. You could have distributed that negative 3 through to both of them instead. Okay, but let's keep going here. So we're not all the way done. So on the top, we still have y to the 2nd, but on the bottom, remember, I need to distribute this 3 to the 2 and to the y to the 7th. And so many students forget that they've got to give that power to both of them, right? So I'm really dealing with 2 to the 3rd power, which is what? 2 to the third power. 2 times 2 times 2, so that's 8. Right? So I get 8 on the bottom, and then y to the 7th all raised to the third, power raised to a power, and multiplying those, so y to the 21st. Okay. But I'm not done yet, because I can see I have y's in two different places. I've got some y's on top, and I've got some y's on bottom, so I've got to get those guys together. Right? And there's more y's on the bottom, so I know I'm going to end up with my y's on the bottom. So my 8's already going to stay there on the bottom. It's happy, right? Doesn't have a negative exponent on it. And y to the 21st is on the bottom, y to the 2nd's on the top. So how many y's do I have left on the bottom? 19. Right? And then there's nothing left on top, but it's not a 0 that's on top, right? It's a 1 that's on top. Because again, I mean, I don't want to write out 21 of these, but if I had y times y on the top, and then y times y times y, right? You can see, oh yeah, I'm still left with 1 over y would be my answer on that. So there's still a 1 left there on the top, and I've got to keep that 1. Because that's not the same thing as, 8y to the 19th. Right? It's 1 over 8y to the 19th. Okay, what question's going to answer there? I know sometimes with these negative exponents, it's like, what? What are we doing? Okay. Okay, let's do another one with negative exponents, and this time I'm going to have you guys work through this on your own, and when you come up with an answer, I want you to raise your hand, so click on that hand raise button so I can see what you're coming up with there, okay? So everybody try this one. What example are we on? Are we on example 4? I don't know. I should have looked. Okay, so let's simplify. X to the negative third, y to the 4th, all raised to the negative first exponent. Okay, so remember, to have it simplified, no negative powers, and you can't have any parentheses, and your variables have to be together. Okay, so take a minute and just do that one. Click on the hand when you get it done so I know when you're finished. More than one right way to work it. So don't be stuck going, I don't know if I'm doing this the right way. Try something. Use those rules of exponents. Okay, only 2 people have their hands up. So only 2 people know how to do this? Or have tried something, whether you get it right or not. Just want to know if you've tried something. Okay, Jordan, will you share with us what you did? You okay with that? Yeah.
I put the equation denominator, the 1 on top.
So you kind of made it into a denominator so that you know there's a fraction? Okay.
So it was x to the power of negative 3 minus the power of 4 in parentheses with 1 on the outside.
Okay. So notice how he kept that negative 3 inside still. So the stuff inside is going to stay exactly the same. That's exactly right. And now the whole thing's just raised to a positive first power, right? All we did there to change it, we had to flip this whole thing downstairs. Okay, keep going from there.
I distributed the 1.
Mm-hmm.
So it'd be x negative 3 y power 4.
Right? Because that.
The 1's still on top.
Mm-hmm.
And then I'm a little confused if I did this right. I just moved the x to the top there.
Yeah.
So that was the numerator, and then I left the y as the denominator. So it was the x to the power of 3 and then y to the power of 3.
Yeah, that's exactly right. Right? Because x was the only guy that was unhappy. Right? The only part that was unhappy was the x. So only x wanted to go upstairs. Y was positive, perfectly happy. Y is staying downstairs. Okay? And so that works.
So I'm allowed to move stuff around like that?
Uh-huh. Yep. Right? So I want you to get into that.
Kind of sense it.
Yeah. No, I want you to get into that habit of just like, flipping them to where they're going to be happy. Kind of like I talked about with my kids in the basement, right? This is probably my daughter that doesn't want to be downstairs anymore because there's spiders downstairs. And so she wants to go upstairs and then she'll be happy, right? Where my son is perfectly happy still downstairs. So he's going to stay downstairs. All right? So we've got to make sure you're thinking of those as, two separate things. Right? Okay. Did anybody start by distributing the negative 1 through first? Yeah? Megan, you're shaking your head yes. Is that what you did? Okay, so when you did that, right, so x to the negative 3 times by negative 1 gives you x to the positive 3 now. And then when we distribute this negative 1 through, we get y to the negative 4. Right? And then at this point, you might still want to put a 1 underneath it because now here we're going to say, okay, now this guy is who's unhappy downstairs or upstairs wants to go downstairs. So we still get that same thing, x to the 3rd over y to the 4th. Okay, so this is just another way you could have done it. Right? Here's one way and here's another way. And either way is great. Okay, so hopefully you've picked one of those ways and we're able to get through there. All right, let's do one with negative exponents that maybe is a little bit more complicated. See if we can, challenge you a little bit more here. Okay, what if we have something like this? Let's do in parentheses, 2x to the negative 3rd power, y to the 4th, and then all raised to the negative 3 power. Okay, so let me give you just a minute, and I want you to try that one again. Simplify that. See how far you can get. All right, and everybody put your hands down again. Put them back up when you've worked through it. Come up with something there. Raise your hand when you have something, so you know, able to kind of get through that problem. All right, Colton, would you be willing to tell us what you did on this one?
Yeah.
Thanks. Where did you start?
I flipped the whole thing to the other side just because I didn't want to deal with negative exponent.
Okay, so you like put it over one and then you flipped the whole thing?
Yeah.
Okay, so on the bottom, so you're going to have one on the top, and then what do you get on the bottom?
I got 2x still to the negative third.
Mm-hmm.
And then y to the fourth. And then all of that is to the power of positive 3.
Positive 3 now, right? Because that negative exponent, only that one on the outside was what he was changing. Right, we're making that positive. Okay, but notice that the stuff inside all stays the same when you flip it. Okay, then what did you do from here?
I distributed the 3.
Okay.
So I got 8x to the 9th power.
The 9th or negative 9? Uh-huh.
And y to the 12th power.
Okay. Stop right there. Does everybody, if you have a question, just unmute yourself and ask your question. Are you okay with where we're at here so far? That 8 is coming from 2 to the 3rd power, right? You got to give that 2 a power of 3 also. Okay, then what did you do from here?
Then I flipped the 8x to the negative 9th power. Since it was negative, I need to flip it back to the top.
So does the 8 and the x go to the top?
Yes.
So what's being raised to the negative power? It's actually just the x. Do you see that? And this is like something so important to kind of see the difference, because a lot of times we're thinking, yeah, these guys are together and they have to stay together, but we're actually going to be flipping them kind of separately. So if we were going to flip that x to the, upstairs, it would actually have to be raised to a negative 1 power. Does everybody see that? That's kind of tricky. So the 8 stays downstairs, but that x to the 9th goes upstairs, right? And then that y to the 12th is perfectly happy downstairs. So this is what we would end up with. So let me take your questions, because that one's kind of tricky, seeing that. Does everybody see why these guys are separate from each other, so we have to flip them separately? Each other. That makes sense?
I have a question.
Yeah.
So I did it the other way. I just distributed first.
Okay.
And that would make it negative 8, right?
So remember that you're doing, it's 2 to the negative 3rd power, right? Let me just distribute this all through. And then you'd have x to the 9th power, and then y to the negative 12th. So yeah, right here, and this is why sometimes, distributing that negative power gets people kind of confused. But let's think about this over here to the side. If I just had that part of it, not the rest of the stuff, then really this is like over 1, right? And so 1 goes on the top, and then I'm flipping that downstairs to be 2 to the 3rd power. So do you see that that still simplifies to be 1 over 8? And that, I'm glad you brought that up, because it's so easy to think that that negative exponent is making this negative, but it's not. It's just flipping the fraction. Right? Do you see that?
Yeah, I can see that.
What about everybody else? Because I know that's a tricky thing, and that's like a place that a lot of students tend to like try and keep straight in their mind and maybe have a hard time with. But, when in doubt, just kind of like distribute it through like this, and then, think, okay, wait a minute, that's really that negative exponent saying, let's flip it downstairs, right? And so then you get that. So let me finish doing this here. So x to the 9th stays on top, right? My 2 to the 3rd goes downstairs, and then my y to the 12th goes downstairs, right? Because these guys were the unhappy ones upstairs. I've got to go downstairs, right? And then I just need to simplify that 2 to the 3rd to be 8. Whoops. And so I still get the same answer. Okay? Either way I do it. But thank you so much for asking that, because that is really important to understand that difference there. Okay? And I bet if we asked people, they'd probably say they did the same thing and made that a negative, because it happens so often. Okay? Other questions that I can help clarify? I want to make sure you're really getting this. All right, let's try another one then. Okay, everybody try this example 6. So this one, the whole thing is in parentheses, and there's a fraction. Okay, so on the top part of the fraction, I've got a to the negative 1 power, b to the negative 4th power. On the bottom, I've got a to the 4th power and b to the negative 3rd power. And then this whole thing is being raised to the negative 3rd power. Okay. All right, let me give you a minute to think about that. Think about where do you think you would start, and then go ahead and try it. Okay. And then raise your hands again once you have an answer there. And if I call on you and you're not feeling comfortable with it, just say, Becky, will you pick on somebody else? I just can't tell, and I can't come around in class like we usually do and stuff. So, but if you're willing to share what you did, I'd really appreciate it. Remember to raise your hand when you think you have it, or you came up with something at least. All right? We always learn from our mistakes too, so I don't want you to ever feel bad if you make a little mistake, because we are learning, and mistakes help us to learn. Okay, let's try this one. Elizabeth, would you be willing? Tell us what you did.
Yeah, sorry, I'm eating a bagel.
Oh, it's okay. Sorry, you saw me eating my lunch too.
Hold on. Okay, so the first thing I did was distribute the -3 to all of them.
Okay.
And on the top I got a to the +3, and then b to the +12, all over a to the -12, and b to the +9.
Okay.
And then I just flipped my a to the -12 up to the top and combined with my a's.
Mm-hmm.
A to the 15th with b to the 12th and 5/9 on the bottom.
No, hold on just 1 second.
Oh, sorry.
No, that's okay. I know. I just want to make sure everybody's with us. So I'm not going to skip that. You put those together in one step, and that's perfectly fine. And I think that's probably what a lot of people did, but I just want to make sure everybody's seeing that she moved the -12, right, the a to the -12 up, and that's where she got that a to the 15th. Okay, and then tell us what you did with your b's.
And then I subtracted those, and since there were more b's on top, I got a to the 15th and b to the 3rd.
Okay. And on the bottom, there's just a 1, but we don't really need a 1 when it's on the bottom, right? When it's on the top, we need to keep it there. But when there's a 1 on the bottom, we don't need to keep it there. So that would be our answer, right? Anybody else come up with those? Raise your hands right now if you came up with that answer. So some of you already had your hands raised, so keep it up. But if you didn't have your hand raised before, this will just help me see how everybody's kind of getting there. Okay, and those of you that didn't get it, will you ask me a question so I can help clarify anything? Just unmute yourself and go ahead and ask me if there's one that you can think of. Some of you did it differently, maybe. Maybe I'll show the other way too, because maybe that'll help some of you to see. So instead of distributing the -3 through, you could have started by flipping everything inside. So when I did that, if you flip everything inside, then it will all be raised to a positive third power. And so the stuff on the bottom, right, that a to the 4th, b to the -3rd now is going to go on top. And then the stuff that was on the top is now going to come downstairs. A to the -1, b to the -4. Remember, you can only, work on one negative at a time. So if you're doing your flipping, right, you're just working on that -3 on the outside, flip everything on the inside, and then it'll be raised to a positive third power. And then on this, right, from there, it's pretty similar to what Elizabeth did before. So we get a to the 12th, b to the -9, a to the -3, and b to the -12. And then you just got to flip things to where they're going to be happy, right? So a to the 12th is happy on top. Got to move b to the 12th upstairs, b to that 9 downstairs, and then a to the 3rd upstairs, right? And then it really becomes, you can see the similarities now between these two and how we get that a to the 15th, b to the 3rd. So even if you started it out differently, you still end up with the same thing, okay? So either way is perfectly good. So just wherever your mind's kind of taking you first. If you're thinking, my mind is just automatically thinking, let's distribute that negative through, then do that. If you're thinking, I'm going to flip to get rid of that negative, then do that, okay? So good job on that. You guys seem like you're doing pretty good with these. All right, you guys can put your hands back down unless there's other questions that I can answer for you on that.
Becky,
Yeah.
it's Ben. Can you remind me how I know it's completely solved? There's no parentheses and there's no
Yeah.
Is there anything else other than those two?
so no parentheses, no negative exponents, and that your variables are together. Right? So on this, we don't have any negative exponents on this last part. We don't have any parentheses on that last part, but we can see that, oh yeah, I've got to get my A's together, so those variables have to be together, and then I've got to get my B's together. All right, so these are the three things that we're looking for. So it's simplified if, right, we have all three of these things. Does that help?
Okay, great.
Mm-hmm.
Yep.
Good question. Always good to make sure we know what that is. All right, well, maybe let's take a little break right now because that's pretty much it on 5.2, and then we'll come back and we'll talk about some 5.3. So let's just take like a little 5-minute break right now. And feel free to unmute yourself and talk to each other though too, because it makes it hard when we're not in class together and we don't get to talk to each other. Or notice that that you can talk to each other in the chat also. So sometimes that is nice as well to be able to do. Or if you want to talk to me, I'd be happy to talk to you too because I miss you guys. All right. Did everybody figure out? Okay, Colton said it's the icon next to your name. Thank you. There should be a little icon next to your name. That's the hand one. And I know some people are saying they were having a hard time with it. So if it's not working, your hand.
I'm not seeing any hand next to my name. Would it be like under the participants?
Yes. Yeah, you have to look under participants.
Okay, I just see a place to mute my microphone.
So that's all there is, but if you scroll over the top of it, there should be if you scroll over your name, there should be a hand that pops up also.
Still just not seeing it. Let's see.
Yeah, I know that.
No, it just gives me the option to mute my microphone.
And then the chat box, does it give you a little chat bubble?
On the chat, yeah.
Well,
I can make
Okay. Yeah, so why don't you just use the chat box to chime in then, if you can't, if you can't get the hand to work, because I think Elizabeth was having a hard time with it last time.
This is an older computer too, so it might just not.
Yeah, and so it's hard to know why it's, working for some people and not for others. I wish I knew. But I'm glad the chat box is there because then you can just respond there too. And, okay. Okay, awesome. I'm going to get up, stretch my legs for a minute, but let's start in about 3 minutes. Okay? But feel free to talk to each other. You guys don't get to see each other now. It's so sad. Yeah. Were you talking to them? Yeah, can you see some of them? You just can't see me right now. What? They can see me, I think. They should be able to. Okay, yeah. Now it just gets so hot in here. All right, so we're going to be talking about scientific notation next. That's what 5.3 is about. But before we explain, exactly how to write things in scientific notation, I just want to make sure that in some of your science classes, you'll definitely be using this. There's a lot of different ways, like when we have really big numbers that we want to try and write them in a different format so that we don't have so many digits out. So like in chemistry, when they're dealing with, elements and stuff like that, and they have, these digits that are like really quite a few of them. You don't want to have to write out all these like 0.000000000, 432 or whatever. And so they kind of try and shorten that down a little bit into the scientific notation. Now there's other notations that you'll be using in science classes too, like significant digits and some other things. But if you understand how to write things in scientific notation, then those other ways that you'll be learning will come a lot easier. So like in physics and chemistry, in biology, they might have you use this and other classes as well. Okay, but I want you to first look at this that I wrote down, because I want you to start looking for some patterns that are happening here. And so if we're comparing, right, the left side of this equation to the right side of the equation, anybody tell me some patterns that you see happening in this list of things that I wrote down? Go ahead.
Notice the exponent. So whatever that number is, that's how many zeros there are.
All right, I like that. So you're saying, I see that the exponent of 3, I'm going to have 3 zeros, right? Exponent of 0, I've got 0 zeros, right? And then with these negative ones, though, right, it's not that you have negative number of it, but it's kind of moving that other way, right? Awesome. Okay, what else do you see? Or maybe how else could you think through these negative ones? Notice that we're always starting off with the number 1. And the decimal on 1 would be here, right? And so also along that same line is what he was saying with the, seeing those, that there's 3 different zeros. It's also talking about the place value. So if the decimal was here, right, and it was saying I need to move it 3 places to the right, then I would end up with 1,000. Right, but then let's look down here with the negative exponent. So again, I start with the number 1, right? So I'm going to look at this one here. Now, number 1, the decimal starts here, right? It's always to the right, right? If it's at like 1.0. But now I'm not moving it, right 3. Since it's negative, I'm going to be moving it left 2 on this one. So let me circle that here. So this is telling me I'm moving it left 2 places. So 1, 2, and so now my decimal point is there, right? So now my number really is 0.01, which is what I said that is, right? And this one is now 1,000. So yeah, this exponent on there is telling you whether you're moving those decimal points left or right. And and the higher the negative exponent, like the smaller the number. There's going to be more digits, but that means it's a really, really, really small number, right? If we had, 10 to the negative 18th power, right, we're going to have like 17 zeros on that. And so it's going to be a really, really small number. Long digits, right? A lot of digits there, but that's a really small number. So that's one of the things I wanted to talk about here with scientific notation, and just make sure that that's clear, to you on that. So let me just ask you on maybe, 2 others here. So what if I said, what is 1 times 10 to the negative 8th power? How would I write that as a number? So that negative 8 is telling you what? Somebody just unmute yourself and tell me what you think. Is that negative 8 telling you to move?
I think the way I see it is that if you count all of the zeros, including the one in front of the decimal, then it'd be 8 zeros and then the 1.
Okay, yeah. So it's going to be, because it's telling you to move it, the 1, right, 8 places to the left. So I'm going to put it here, right, and then if I move it 1, 2, 3, 4, 5, 6, 7, 8, right, so I fill those in, but then she said, yeah, she thinks of it as, maybe I'll erase this here a minute. But they're saying, yeah, so I'm still going to have 8 zeros, right, on that. But you've just got to make sure that you know where that, the zero is going to go between those first 2, right? Or you're starting here at that decimal point, moving it 8 places to the left, okay? And then the same thing is true if we had one, going in the positive direction. So 1 times 10 to the 12th power, I'm saying start with 1 and move that, right, 12 places over. And this is actually going to be how many zeros you're going to have because your decimal starts up there. So, right, maybe put these in so we can kind of see. That's a huge number, right? And so we wanted to be able to take things that have a lot of digits in them and rewrite them in such a way where they don't have so many digits, so we can kind of see what's happening. And some of your calculators will actually do that too. I don't know if you've noticed it, but if you get like a really long answer, sometimes it writes it in this kind of weird form and you're like, what is it doing? I know that can't be the right answer. And some of them will have like these little, well, it will kind of show you the exponent above it, but it doesn't always quite look like this, like scientific notation. Sometimes you'll see like a little like EE in there or something, and that's telling you that it's using this scientific notation. Okay, so just watch that when you're using your calculators too on this, because that could be happening there. All right, so let me just say a little bit. So what you need to know about scientific notation is you're going to have something always in this form of this a times 10 to the b power, right? And this a, whatever the number is that we're multiplying by, has to be a number between 1 and 10. Okay, so it can be equal to 1, right? But it can't be bigger than 10. So it has to be, 1 and then up to 10, like 9.9999999, right? But it can't be 10. So number between 1 and 10. And then this exponent here, right, can be a positive or negative number, right? So it really can be anything. And this is telling you, how the decimal is being moved. Let's see how many places, I'll say. Okay, so it's not in scientific notation if our number out here was like, if it said, 23.8 times, 10 to the 5th power, right? We'd have to have this decimal point has to be there between our 2 and our 3, because the number that we have here for A has to be a number between 1 and 10. So it couldn't be 23 point something, it'd have to be 2.38. And then that's going to change this also, right? And so we'll kind of talk a little bit about that when we're doing these, but just know that it has to be, this number, this A has to be a number between 1 and 10. Okay, so let's look at a couple of these and convert these in the different ways that's being asked. So for the first example, I want you to convert 14,200 to scientific notation. So our decimal point, starting off, is at the end here. And we said in order for it to be in scientific notation, right, I've got to move that decimal point so that my number is now between 1 and 10. So I have to move it more than that because that's 1,420. There's 142, 14.2, and then I've got to move it here, right? So that it's saying 1.42. And then you can just get rid of the rest of those zeros. If there's like 10 zeros at the end or whatever, you just, those decimals just fall off there, if they're zeros. And then times 10 to the amount of places that we moved it, right? So since we moved it 4 places, it's going to be to the 4th power. Now, sometimes people get confused and go, well, wait a minute, why wouldn't that be negative 4? Because we moved it to the left 4 places. But think about this number, right? This 14,200. That's a number that is bigger than 1. It's not a really small number, right? It's a really big number. So bigger numbers are going to have positive exponents, right? Smaller numbers, again, I'm not meaning digits, I'm meaning size-wise, right, are going to have negative exponents. So I know this is going to have a positive exponent on it. And it was moved 4 places. Okay, let's look at another one. Oops. Okay, so for the second one, let's do so 0.000485. Right? So again, so when I'm looking at this, this is a really small number. It might have a lot of digits, but 0.000485 is a small number. So I know that my power that it's going to be raised to this time is going to be a negative exponent, right? And again, I'm going to move it. So it starts off here, but I've got to move this decimal so that my number is between 1 and 10. So does everybody see that it needs to go there? Because if I move it in front of the 4, 0.4 is smaller than 1. And if I move it after the 8, 48 is bigger than 10. So it's got to go here. All right, so my decimal part is 0.85, or sorry, 4.85. I don't know where my 4 went. And then times 10 to the what power? Can you tell me what power you think that would be raised to? Go ahead and unmute yourself and say. Okay, yeah, sorry, some people were putting in the chat and I didn't notice that you were saying it there, but yeah, to the negative 4th power, right? We said it has to be negative because it starts off as a really small number and we moved it 4 places. So that's why it's a negative 4. Okay, so maybe just write a couple of things over here to help remind you here. Let's see, how do I want to say it? I had
Quick question.
yeah.
So, like, if the number already is smaller than 1, like this one, it's going to be negative because we have to move it. Like, will that always be the case?
Yes.
Or, okay.
Yeah, and that's what I was going to try and write down here to the side. So if the number, right, in just regular notation is bigger than 1, then the exponent is positive in scientific notation. Right? But if the number that you start off with, right, is smaller than 1, then the exponent is negative in scientific notation. Okay, and those are absolutes. That is always the way it's going to be. So I think it is easiest to try and ask yourself when you're converting to scientific notation, is this a really big number or a really small number? And just starting off by asking yourself that question will help you keep straight whether you need to have a positive, exponent or a negative exponent in your scientific notation. Okay. Does that make sense? All right, let's try going the other way also. So sometimes they'll give numbers to you in scientific notation and they'll want you to change those to standard notation. All right, so just a standard number. So example 3, let's do, what if we have 2.31 times 10 to the negative 7th power. All right. Try that one, and then I want you to also try this next one. So try both of those. So write these in standard notation. Okay, so in example 3, are we going to be moving the decimal point to the left or to the right? Go ahead and just say out loud. Just unmute yourself.
To the left.
To the left, right? Because it's going to be, or left, because it is a negative exponent. Okay, so if I move this to the left 7 places, 1, 2, 3, 4, 5, 6, 7, and that means my new decimal point is there. I'm going to fill all of these in with zeros. Right, so then my answer, if I'm writing out my answer, that's 0.000000, and then 231. Right, and I expect this to be a really small number, lots of digits in it, but a really small number because I raised it to a negative exponent. Okay, and then on this one, since it's a positive exponent, I'm going to be moving that to the right 9 places. And so that means it's going to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then fill the rest of these in with zeros. So notice that on this one, we're not going to have 9 zeros there because there was another digit that took up one of those places, right? So just be really careful with that. This number means how many places you're moving that decimal point. And so my answer there, so 580, 000, 0. Make sure I have 2, 4, 5, 6, 7, 8. I put one extra 0 there, I think I did. Then be really careful with that. And so there would be my answer. Moved it 9 places to the right. Okay, so that's going to be part of your assignment. Just, changing from scientific notation or taking it from scientific notation and changing it back into a standard number. But then the other part of this assignment is going to deal with, well, what if we are multiplying or dividing the numbers together that are written in scientific notation, right? And this is where the properties of exponents will actually come in really handy because you don't want to always, take that number that's in scientific notation and write it out as a big long number because it could be like, 10 to the negative 23rd power, and it's going to be this huge number. And your calculator is not going to be able to deal with that many digits anyway. And so we want to think about how could we use the properties of exponents that we just talked about in 5.1 and 5.2 to help us with this. Okay, so let's look at a couple like that. So give you this one. All right, so our directions on this are to multiply and simplify. We're given, so one number in scientific notation, 3.28 times 10 to the 3rd power. We're going to multiply that by 2.4 times 10 to the 4th power. So remember before when we had something like, 2x squared times 5x to the 3rd, we just multiplied the whole number parts together. Okay, and that's what we're going to do down here is multiply the whole number parts together. And then with the exponent parts, right, since these guys have the same base, x and x, then we can add those exponents together. And that's what we're going to do on this part because I can see my bases are the same. The base is 10, and then I just need to add those exponents together. Okay, so first of all, in your calculator, let's figure out what that 3.28 times 2.4 is. When somebody has that, will you tell me what that is? It's 3.28 times 2.4. Just do it in your calculator.
7.872.
Okay, 7.872. Is that? Okay, so that's going to be, oops, I should have done this in the other color to make sure, just try and match these up, right? So when I multiply those together, I get 7.872, and then times 10 to the what power? So what am I going to do with these exponents? That's 7. We're going to add those together, right? On something like this, right? X squared times x to the third is x to the fifth, because we're adding those exponents together. So on this one, we'll do 10 to the 7th power. Right? And then that would be your answer. You need to check to make sure that this is still written in scientific notation, meaning that, you know, the number here in the front is between 1 and 10, because sometimes when you do this multiplying together, sometimes we get a number out here that's not between 1 and 10, and so we've got to move it, okay? And so we'll talk about what to do on another example when that happens, but we are good. That would be the answer there. Okay, what other questions do you have there on that one?
On the homework, you write it that way and not in standard?
Right. You want to write it, so if it gives it to you in scientific notation like this, then they want you to keep it in scientific notation for the answer. Good question. And that's the whole idea of, like, this is helping us, you know, use those properties of exponents that we did before. We don't want to, I mean, to find the answer to this, I could do, you know, 3.28 times 1,000, and then do 2.4 times 10,000, and then multiply those two numbers together. But it wants you to leave it in scientific notation. And these aren't very big exponents, but like in your science classes, you're going to get really big exponents. And so, like I said, those digits aren't even going to fit in your calculator to do it like that. So, got to make sure we're doing it this way. Okay, let's try another one, another multiply one, see what you can do with this one. Okay, so everybody try this one on your own this time. So same instructions, you're going to multiply and then simplify if needed. And that means to change that first number if needed. Okay, so I've got 6 times 10 to the 5th power. And then I'm going to multiply that by 4.7 times 10 to the negative 2 power. Okay, let me give you a minute to try that one out. What are we going to do there? Okay, so what is 4.7 times 6? Okay, 28.2. You can see if that's what you got. You're just multiplying those numbers together that I underlined in blue. Right? And then times 10 to the what power? To the third, because I'm doing, you know, I'm adding those exponents together. 5 plus a negative 2 is 3. Okay, so is this written in scientific notation? It's my answer in scientific notation right now. So is my number in the front a number that's between 1 and 10?
No.
Okay, so it's not quite written. It looks like it's scientific notation, right? Because we have times 10 to the something power. But I've got to move this, got to move that decimal point so that it's between, right, that the 2 and 8, because I need 2.82. Right, so if I have 2.82, right, that's going to change what my power is here. And this is sometimes where people get confused on, am I going, is it moving it up one? I know I'm moving one place, but is it going up to 4 or is it going down to 2? Right, and so one way that you can think about it, I'm going to just say it this way, if we took this number that we started off with and just change that to standard notation. Sometimes that helps people to kind of think through it and which way it needs to be moved. So if we had our, let me write it out here again. Whoops, so we had 28.2 times 10 to the third power. That's not anything there. Okay, and then so it's saying that I'm moving my decimal point 3 places over. So that's really saying 28200, right? But then if I was to take this number and change it into scientific notation from here, right, then I'd be starting here at the end and I'd be having to move my decimal so that it's between that 2 and the 8. And how many places did I end up moving it? End up moving it 4 places. All right, so this is going to be to the 4th power. So if I have 2.82, right, I moved it 4 places. But other people can, think about it other ways. They're like going, well, I'm, going, 1 place further away. So that's telling me that it's 4. Anybody else have another way, like to think through that? Why it would be a 4 and not a 2? Do you have an idea of what you could say? Because sometimes you guys have some great ideas and you're like, yeah, I think of it this way. And then usually, click with somebody else. Okay, what about questions on that? Or do you see why it's to the 4th power, not to the 2nd power? It might be hard to tell looking at it here, but if, like I said, you take that, change it to standard notation, and then take that standard notation and change it back to scientific notation. That usually works for a lot of students, rather than trying to remember, okay, am I moving it to the left or to the right or what? Okay. Can't tell if there's any questions on that. Raise your hand if you have questions. I know this isn't the most ideal way. It's hard for me too, guys. Trying to, see what you guys are understanding or not. Yeah.
Sorry, my computer died as you were talking about this problem.
Uh-huh.
So can you just go over real fast why it was to the 4th instead of 2 and 3 or something?
So I changed it. So notice I took what it originally was, that 28.2 times 10 to the 3rd power. I changed that into standard notation. And then I changed that back to scientific notation. So if it would ended here, I'd have to move it over 4 places to get it. So my decimal is between that 2 and that 8.
How did you get the 28.2 and stuff? Where did that come from? Is that the 6 or 4 times?
So yeah, so 4.7 times 6 is 28.2.
Oh, okay.
Right, and then we just added those exponents together to get our power of 3. Okay?
Thank you.
Yep. Okay, let's try another one. On this next one, we're going to do a division one. So remember that, well, let me write this down first and then we'll, which example are we on here? 7. All right, so if I have 9 times 10 to the 7th power divided by 4 times 10 to the 3rd power. Okay, and again, trying to relate this to stuff that we've already talked about. If I had, 10x to the 5th over 2x to the 3rd, right? Remember how we were just trying to combine things together. So I do my 10 divided by 2, reduce that part, and then do my x part, right? And then I'd be subtracting those exponents because it's connected by division. So in this, I'd get 5x to the 2nd power. 10 divided by 2 is 5, and then there's 2 more on top, and then there are on bottom. Okay, so that's kind of what we just did, and now we're relating it to this. So we're first going to start off by dividing those two out. So in your calculator, what's 9 divided by 4? Because I want it as a decimal, not as a fraction.
2.25.
Yeah, so 2.25, right? So I'm just dividing that. And then the other part is I'm going to take this, and when I'm dividing those, I'm really subtracting my exponents. Mm-hmm. So I get times 10 to the 4th power. Okay. And then I've got to double check and make sure, is this in scientific notation? Is this number out in front between 1 and 10? Yeah, it is. So I don't have to be doing any of the crazy stuff like I had to do up here, right? 28.2 wasn't scientific notation. I had to move that one place over so that it was, right? But this is good, just the way it is there. So that would be my answer.
So on the exponents, you always subtract the top from the bottom?
Yes, it's always the top minus the bottom. Okay. Yep, it's always that way. Okay, let's try another one. Let me try this one now. So let's do, on the top, I'm going to have 1.081 times 10 to the 2nd power. And then on the bottom, 4.7 times 10 to the negative 8 power. Okay, so I'm going to try that one. See what we can do there. And make sure when you're putting these in the calculator, right, you're doing so the right way. You're always doing your top number divided by your bottom number. So you put your top number in first, and then divide sign, bottom number. Okay. So what do you get there when you divide those out? So 0.23 is what you get. So that's going to be our first part of our answer here, right? Part of our science as we're writing down the scientific notation. And then let's do the other part here, right? And so with this one, it's a little bit different because before we were saying, well, we need to like flip them so that they're always positive, but with scientific notation, we're not always going to have positive exponents. So you really do need to follow that rule that we were talking about here, where we're doing the top minus the bottom. So in this one, we're doing the 2 minus a negative 8, right? And 2 minus a negative 8 is really going to give us 10, right? Did everybody see that? Okay, is that what you got there? So we've got times 10 to the 10th power. Okay, but is this in scientific notation, or do I need to change something? Is that 0.23 between 1 and 10?
No.
No. So we've got to move that. Again, kind of like we did on the one, above there. So we know we've got to move this, right? It's got to go between the 2 and the 3, right? Is where we need to move it to. But again, if it's easiest for you just to change this to standard form, right? And you're going to get to the point where you're not going to have to do this, but it might help to start off with, to, think it through this way. So we're saying, okay, I'm moving this 10 places over, right? So it started here, and I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And I'm filling these all in with zeros. But then I'm really trying to count up, okay, what would it be to get my decimal point back between the 2 and the 3, right? Because I need to have it as 2.3, and so that would be times 10 to the what power? Yeah, it's going to be to the 9th, right? And so, you can just count it up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it might help starting off changing it to a regular number and then changing it back to scientific notation until you kind of get the hang of whether the exponent's going to be going up or down one place. Okay? And you might find some things that work for you, and I'd love you to share those with other people as you're doing your homework and stuff like that. Maybe you'll come up with something you're like, oh, I think of it this way, and that really helped me out, because other people in the class will really appreciate that, I'm sure, too. But it's harder to say that you're going to be going always to the left or always to the right, because depending on whether you have, you're starting off with a negative exponent or positive exponent, that's going to kind of switch things up there. Okay.
So I kind of think of it as if you need to make your number bigger, you have to borrow it from the exponent. That's what makes it easiest for me.
Oh, I like that. I'm going to write that down. So if you need to make the number bigger, okay, say that again.
Then you need to borrow it from your exponent. And the same would go for if it needed to be smaller, then you would add it to the exponent.
Oops. Awesome. I like that. So if you need to make the number smaller, then you add it to the exponent.
I also just noticed that bigger and borrow both start with B.
Yeah, awesome. I like that too, right? Just any little things that you can find that help you, kind of think of this as a bigger number, you're going to borrow, right? And borrow means it's going to go down. Where if it's smaller, you're going to add. It's going to make it go bigger. Okay? Make the exponent increase. Or I guess, well, not always. If you're adding it to it, it could make it decrease if it was starting off with a negative. But yeah, but if you follow those, that will definitely get it to you there. Adding or subtracting those there. All right. So remember, so I want you to work on 5.2 and 5.3. We didn't get through 5.4 4, which was on the schedule to get through. But just work on, so 5-1, 5-2, 5-3, and then, because that's what we did last time was the 5-1. And then just make sure that you get, some of this stuff done before next time. So, because we're going to be building on these ideas and stuff, and it will be a lot more helpful if you kind of have this down for what we're going to be talking about next. Okay. I'm going to go ahead and stop there, but if you guys have some questions and you want to stay on to ask me some questions, that is great. I'd be happy to stick around and answer those for you. Okay, and also remember that you've got that learning strategy to do too. Okay, and there's not going to be a learning strategy for Module 6, so this will actually be your last learning strategy for the semester. Okay, so just get that done, and then you'll have all your learning strategies done, and we'll talk about the reality check probably not next time, probably on Tuesday next week. Okay. Any questions? If you have individual ones, like I said, you can stay on and I'll answer those for you. What was that?
Is the module 4 quiz tonight, or is that tomorrow?
The Module 4 quiz was due by tonight at midnight.
Okay.
If you're going to have some issues with that, send me a message, and just make sure. I just want to make sure. Remember that your Module 1 test and then 2, 3, and 4 quiz scores are going to be your exam number 2. And I opened up your, 2, 3, or 2 and 3 so that you could redo any of those that you wanted to until April 19th. Okay, so you have some time to work on those and get them done, but I just wanted to make sure you remember to do that. Okay. Anything else? All right, have an awesome day, guys, and we will talk to you on Thursday. We'll see you on Thursday in class, okay? Oh, remember also, I do have online office hours for this class Wednesday nights. So from 5 to 7 p.m. If you are struggling with any of this, please come to those online office hours. Okay, and if you have questions about where I hold those, then just message me. Okay, have a good night, a good day, see ya. Thanks for coming, everybody. Did you have any questions, Ashton?